All right, back to our regularly scheduled program. All right, we're going to introduce this using one-dimensional signal, and then we'll go to 2D. All right, so here we have a signal, and it's a 1D signal. And here's a filter. And that filter, if you take a look, actually, this filter here looks a lot like, oh yeah, you know, something like that. And that's because I made this and I actually pulled out that chunk, okay? But the system doesn't know that yet. And what we're going to do is we're going to do the normalized correlation of this filter with that signal. When you do that, you get a result that looks like this. And you'll notice its maximum is at this peak here in red, right? Right here, okay? And that's the location of where this filter came from out of that signal, okay? So the highest value is exactly when these things match. There are a couple of reasons to explain that. Here's the one that I like best. Pretend for a moment that both of our signals were normalized so they were sort of shifted so that they were about zero. So sometimes they went positive and sometimes they went negative, okay? And remember, we've got the scale being approximately the same because they scale up so the standard deviation is 1. If I take one filter and I lay it over the image and I'm going to multiply them and then sum them up, remember, some of my values are positive and some of them might be negative. I realize this is the first time we've talked about negative signals. In fact, on the drawing here, you'll notice it's 0 in the middle. But if I've got positive numbers and negative numbers, and I've got positive numbers and negative numbers in my filter, if I want to do a multiplication and have it come up as high as possible, when does that happen? Well, the obvious intuition is, well, whenever my pixels in the image are positive, I want my coefficients in my filter to be positive. Because positive times positive is what, Megan?
Positive times positive?
Yeah, positive. And what do I want where the image is negative? I want the filter coefficients to be negative also, right? Because negative times negative is what, Megan?
Positive.
Positive, very good. Yeah, she went to film school, but she's doing great. Anyway, and so if you think of sort of a filter as having, because we've scaled it, you know, it can't go arbitrarily high and arbitrarily low. If you get that signal to be lined up exactly, so wherever it's positive, the other one's positive, and where one is negative, the other is negative, you get the maximum value. There are a lot more sophisticated ways of showing this involving differences in distributions and things like that. They all basically will show you that the maximum value you can get, the product of these, is when they're exactly the same.